Never have I had a student who told me they liked fractions. So let me show you a good way to deal with fractions to make it easier. We want to get rid of those fractions, and the way we do that is we look at all of the denominators, which are 3 and 2. There are two denominators that are 3, but still, those are the two unique numbers. So we need a number that both 3 and 2 go into. Well, 3 times 2 equals 6. 3 goes into 6, 6 divided by 3 is 2, and 2 goes into 6, 6 divided by 2 is 3. So 6 is our number. If we multiply both sides of this equation, or every single term, by 6, we still have an equivalent equation, but what we will do is be able to eliminate fractions. Now, first of all, I want to point out when we're multiplying fractions by a whole number, instead of writing it as 6, we're going to write it as 6 over 1 since we're multiplying fractions. Now notice I kept the x, but I just stuck the 6 over 1 in there. We can multiply in any order of that term, but we just have to multiply every single term in this expression by 6. Okay, now let's look at this fraction here, these 2/3 times 6 over 1. When you multiply fractions, what you're really doing is multiplying the numerators, and then you multiply the denominators, and that gives you your new numerator and denominator. But then you would have to reduce. It's easier to actually reduce first. So 3 goes into 6 2 times. Here's how I do that. I say 3 goes into 3 once, 3 goes into 6 twice. So now I'm left with 2 times 2 equals 4 over 1, which is really just 4. Okay, plus, and then 2 goes into 2 one time, 2 goes into 6 3 times. So multiplying my numerators, I get 3 over 1x, which is just 3x, equals, and then 3 goes into 3 once, 3 goes into 6 twice, 8 times 2 is 16 over 1. So that's going to just be 16. So now we have an equation that has no fractions in it. All we have to do now is solve for x, and to do that, we want to get the x term by itself. So that means we want to get rid of this 4. We're going to subtract it to get rid of it. But if we subtract a 4 from one side of the equation, we have to do that to the other side also. Now what I want to do is get my x by itself, and I can do that if I divide by 3, but again I have to do that to both sides. The 3's cancel here, leaving me with x, and 3 goes into 3 once, 3 goes into 12 4 times, and I get 4 over 1, which is 4, and that's my answer. And it's a good idea to check that. Let's look at our original problem and rewrite it with x equals 4. 2/3 plus 1/2 times x, and remember, when we're doing a whole number, we need to convert it to a fraction in order to manipulate it with fractions. So the question is, does 2/3 plus 1/2 times 4 over 1 equal 8/3? Well, 2 goes into 2 one time, 2 goes into 4 2 times. So we have 2/3 plus 2 over 1 equals 8/3. And we can multiply everything by 3. 2/3 times 3 over 1 plus 2 over 1 times 3 over 1 equals 8/3 times 3 over 1. And the 3's cancel. And so we have 2 over 1 in the first term is 2, plus 2 times 3 is 6 over 1 is going to just be 6. So does 2 plus 6 equal 8? And it does. So now we know that x equals 4 is the correct answer.